You can see the close up of the Airbus A319 with these positions at which the pilot can or the flight operator can prefix it. And this is on Embraer EME 170. Again you have up and down controls on the angles. This is conventional, where you have a tailplane here and the wings here. You could have canard in which the tail is in the front like this or like this. These two canards are different. One of them is a control canard, one of them is a lifting canard. Now this distinction I don't want to tell you, I want you to figure out on Moodle and tell me. In fact, there are three types of canards. There is a close coupled canard, there is a lifting canard, and then there is also a control canard. So you have to tell me what the differences are and how they are. This is a very interesting plane which has got a canard also and a conventional tail also. So we call this as a three surface aircraft. You have canard, wing and tail. And we talk about this aircraft a lot in our aircraft design course. I don't want to spend that much time here because in the aircraft design course, of course, this will be covered in more detail. Then you have elevators. This part is the elevator, which is the movable part of a tail. Sometimes we have all moving tails also, mostly in military aircraft, but transport aircraft normally you have a fixed part called as a stabilizer or a fin and the moving part called as the elevator. Alright, so now the interesting thing is that here you have an elevator and you have a small deflecting surface over the elevator. So what is this? A small elevator on the elevator. This is a trim tab. This is a tab which is a small deflecting surface but a fixed surface. So you deflect it at some angle and lock it. It is used to reduce the hinge moment required to operate the stabilizer. We will study about this more when we do the stability. Okay, so trim tabs basically they reduce the force on the control yoke or control stick and they are meant for trimming the aircraft. Alright, this is the vertical stabilizer, which is a flat surface, sometimes 1, sometimes 2, sometimes 3 on the center line of the aircraft, on the rear side, in the front. It gives directional stability, so it gives you the tendency to avoid going into a yaw uncontrolled. If there is a disturbance, you will fly straight. If there is a disturbance, you will avoid going this far. You may go and then come back. Okay, that is called stability. We will discuss about it. But it also has a small moving part called as a rudder, which is meant for intentional motion. So the pilot deflects the rudder to intentionally go into a roll or into a yaw, but the fin or the vertical tail is needed for stability. Okay, so vertical tail can also be conventional like this, just a single one, okay, directly on the empennage, most common configuration. But you may also have a T tail that looks like a T. This is also a tail, but that horizontal tail is moved up and away. You can also have a twin tail. That means you have two tails mounted at the ends. And why do we have them? What is the advantage, etc.? That we will discuss in the aircraft design course. Then you can have again the twin boom, twin tail. And you can also have something like a V tail. This is F117A and this is the Beechcraft model 35. It has got a butterfly or a V tail. Here, instead of three surfaces, vertical 1 and 2 horizontal, you have just two surfaces. So apparently it reduces on weight, reduces on drag. Okay, but read about this more. It's a very interesting configuration and there are not many aircraft, there are only about 4 aircraft that I know which have a vertical tail. Then you have triple tail. Again, I have not seen a quadruple tail. Although there are some aircraft in the beginning which had multiple tails just for trial purposes, like the Louvres Okay. Now, in this picture, I want you to focus your attention on the part which is required when the tail isn't enough. Then you have to have extra things, and that is a ventral fin. This is the MiG-23 with a ventral fin. Okay. What is a ventral fin? Something mounted at the rear underside of the fuselage. It improves responsiveness towards rolling. We will see this when we look at the stability classes, and it also improves the directional stability of the aircraft. That means if the aircraft has a tendency to go into this kind of a motion, it will have a force acting on the back, on the bottom, it will try to bring it back on itself. So it's not common in many aircraft. In some aircraft, like in MiG-27, there's a very interesting configuration that as soon as the aircraft touches down, the ventral fin will bend 90 degrees. Because if it doesn't bend, it will hit the ground and it may break, especially at high angles. So we wanted to have a large ventral fin, but we did not have space to mount two of them. There was only one in the center. So they have a coupling system. The moment landing gear is hitting the ground, it is sensed that it has touched the ground by some pressure, and a switch is activated, the ventral fin becomes 90 degrees bent. That is an interesting configuration. Okay, podded engines is basically jet engine engines inside a pod, which is basically a nacelle, about which we have already spoken. There are many variants. You have underwing mounted, which is most common, and the Boeing aircraft company was the first aircraft company to try out these kind of configurations, below the wing podded engines, and they made it work very well from Boeing 707. After that, every jet engine normally has this. And there is a member which connects the wing to the engine, and that member is this particular component, and that component, you can see it here also, this is called as a pylon. Okay, because it is used to pile the engine on the aircraft. That's why it's a pylon. That's the way I remembered it. Okay, you can also have a pylon for any external store like a bomb or a missile or a rocket pod that will contain the electronics, weapon control system and other devices. In many aircraft stores or armament, you need to have an ejector so that you can push the store down to avoid the store hitting the aircraft. You know, if you release a bomb is an aerodynamic body, and it's a body which can actually start floating up because of the aerodynamic forces, so much so that it may hit the aircraft which launched it. There have been such cases where you have damaged your own aircraft by lodging an armament. The worst offender are the drop tanks, because drop tanks are basically external fuel tanks which are mounted generally on the bottom of the fuselage or on the two wings, below the wings. They carry extra fuel, so if you want to have larger range, especially in military aircraft, what they do is they mount 1 or 3 drop tanks, and then they consume the fuel from drop tanks first, and then you release them, and then you switch over to the internal fuel. So by the time you take off, climb and reach some place, you now have full internal fuel for the mission. Now these drop tanks are lightweight now because fuel is gone, large aerodynamic bodies, they float and they may hit. There have been many studies. One of the last things I did when I was in HAL Nasik was to look at the aerodynamics of store separation, and today also it's a very big area of study. Okay, but you could also have engines over the wing, like these two examples. There are also more examples. And then you can have engines over the wings or halfway over the wings in the front. This particular variation is called as the upper surface blowing, or USB, where the exhaust of the engines is used to flow it over the wing. So this is called as powered lift. You combine the propulsion with the aerodynamics by using the exhaust of the hot engine flowing over the wing. Okay. Again, there are many variations. You could have engines mounted on the back with pylons coming out, such as in this particular example. Okay. Now, the question is, why are these configurations normally seen only on small jet planes? Don't answer it now, read about it and answer on the Moodle page. Why is it so that most large transport aircraft, they will have engines below the wing, but most or many small jet engine aircraft, especially business jets, luxury jets, they may have engines mounted in this fashion. Okay. So, what could be the reason? You have to figure out by looking at the Moodle. Again, more variations. Single engine mounted above with a butterfly tail. Yes. Yes. Yes, MD-90, see MD-80, there is one variation which has got one in the tail and two in the fuselage. Okay. Yeah, that's not a very small jet. But generally you will find large jets we don't have like MD-90. Normally they are mounted below the wing. It's only in the small jets that you basically have examples of this. Okay, this is the most useful thing as far as the pilot is concerned. In case of any emergency, the pilot uses this to save life. This is the ejection seat. I don't know whether we have a video of this embedded.
In the skies over Calgary, an F-18 pilot practices maneuvers for an air show. Would be cheating death.
Lost control.
Had he bailed when the plane was still horizontal, he might have floated.
But when one pilot gets his signals crossed, teamed with a daring high-speed pass, slams into his friend's aircraft, breaking it in two. Seconds after the collision, Sergei ejects. He cannot find Alexander. All he sees is a rage. As we watch again, we can see that Alexander is able to eject from the fiery fuselage just in time.
But after a turn out of the square loop in the midst of slow flight at 500 feet, something suddenly and dramatically went wrong with the right engine.
Harrier. Crash landing, nose broken. Pilot is still waiting. The plane is on fire. But when the fire reaches there, then the pilot will eject. Very risky to wait for so long till the fire is coming in the front. Okay. So all these are ejection seats, and many a times they happen accidentally also. While doing maintenance, some mechanic or someone does something and then another mechanic is launched. It has happened. We are laughing, but people have died. I know of cases in HAL where there was a false ejection like this and the poor mechanic hit the ceiling and he was literally unrecognizable because of the sheer force. Okay. So, one ejection took place by Wing Commander Rakesh Sharma when I was the aerodynamicist also. He was coming into land and 10 kilometers before the Osier runway, there was some problem which was further investigated, but he was able to eject. After ejecting, he came down and he got stuck in a tree. And then from the tree he had a fall, so he broke his ankle. So he was without flying for about 3 or 4 months. But then obviously he came to the HAL and there was a huge party for the ejection cell team because the ejection seat worked and saved his life. Okay. Right. I would like to just spend very few minutes about, while collecting data for this particular course, I came across this very nice documentary of the first female fighter pilot in Asia. Okay. Lieutenant Mariam Mukhtar, who was from Pakistan. So there is a very interesting story that this is the FT-7PG is a Chinese aircraft. You can see there are two, what do you see? 2 ventral fins are mounted. And what about the intake? It's a nose mounted intake. So this is an authorized licensed version of a Chinese aircraft, which was a copy of a Russian aircraft. Okay, it took off with one squadron leader as the teacher and Mariam Mukhtar as the flying officer, and there was a crash, and there is a very beautiful documentary documenting her life and also this whole incident. The most nice thing to know is that she could have saved her life by ejecting early, but she decided to divert the plane away from the population, and in the process save the life of people on the ground. She was going to hit a school, and she said there are going to be many casualties of young children, and instead of that she tried to steer the plane which is having a malfunction. Her captain has ejected and he saved his life, but she ejected late and she gave her life for the welfare of the people on the ground. Okay, so this was the first martyr also.